they are really, they're curious in class, but here it's like the curiosity is just to a whole other level. So that's really fun as a mentor to be a part of.
Their cells aren't treated yet, but I transferred them from a growing flask to these plates yesterday. And so in order for them to be treated, I have to make sure that they're healthy in the plate and basically sticking to the bottom of the plate instead of in the medium. I think that I've seen a change already from the first day. It's a lot less guided now. We kind of know what we're doing, what we're supposed to be doing.
We put them into these little vials and we do a lot of steps involving washing and transcribing different the strands of RNA and then centrifuging them through a filter in order to get just a pure concentrate of RNA. So that's how we run our tests to see if our treatments, how much gene expression there actually was in between the gene expressions of I'm using kisspeptin, which is a hormone, and then I'm using tunicamycin, which is a chemical that's toxic.
One of my reactions just got done. It's with a fairly reactive, kind of hazardous material. So I'm trying to quench it, react it with water to make less reactive, less dangerous things. In a lot of ways, this synthesis has been really hard. This is the second summer I've been working on it. And the compound I'm trying to make has a sulfone in it, which makes it an interesting thing to try and purify. It's more water soluble, which actually makes it harder for organic solvents to do what they need to with it. It's been frustrating, but rewarding all the same.
Then I realized kind of in lab how important it is to document things properly, because then you could end up in a rut and then you won't know where your product is and then you'll have to start all over again. It's definitely worth the extra effort you put in to make it all nice and meticulous.
We put our products on it to essentially get any solvents off. So in this case, we do it to get water off because it's the hardest to, boil off at room temperature by just using negative pressure. And so we're just trying to make sure that we have all the solvent off so that when we take a mass of it, we have the mass of just the product.
There's things in here that we don't do in class just because there's a lot more people in class, so it wouldn't be feasible. So it's more hands-on and more in-depth in what you're doing. So that's good learning experience.
We're working on building some circuitry to basically hold a signal so that we can take in data at the proper time from a scintillator bar.
Based off what types of light they absorb, we can determine with pretty good accuracy what concentration of chemicals are in there. It has really helped me to just have a love for research. It's helped me a lot, and it's given me a lot of good experience.
There's so much more that can be done with the 3D printer, because if you can design it in a way that it will print from the ground up, you can have it. It's a wonderful tool because you can do so much with it.
It's been great, actually. I mean, coming in this is my first year at Wabash, so I'm an upcoming sophomore. Coming and being able to mess with the instruments and do actual testing here, especially with somebody who's going to be an upcoming senior and actually one of the professors on campus, it's been awesome. I completely love it, and I mean, the whole point of getting in this summer is, one, to get experience, right, and then two, to try to find, whether this is the right area for me or whether I should look somewhere else. And I have to say that I was never expecting, if you were to ask me a year ago if I was going to be in a 3D printing lab for chemistry, whether that was going to be a thing for me, I would have never expected that. So it's both an honor and an unexpected blessing to be in here.